Hey everybody, welcome back to Young Engineers of Today. Um, my voice probably sounds different again. It probably sounds like I'm eating a microphone, and that's because I'm wearing a headset, and so I'm still actually working out the distance it should be from my mouth. I'm still a little bit sick, which means I'm breathing through my mouth a little bit more than usual, so it probably sounds like you can hear the mouth breathing. I apologize for that. Um, but with that in mind, after that reveal of probably too much information, how was everyone's weekend? Hope it was good. Good. That was all right. My well, I mostly spent it being sick, but it was a good opportunity to sort of do nothing, I guess, which is nice, which is nice. Um, but thank you for asking. I appreciate it. Um, any exciting stories? Any tales of adventure? Nice. Hiking is fun. I should actually I should do hiking sometime soon. It's been a while since I've done it. It's always fun. Well, you always say that, and about midway through you go, "Oh, I hate this," and then about three-quarters of the way through, it's okay again, and everything's all right. But that middle bit, whew, man. Anyway, that's pretty cool though. That's pretty cool. Oh, nice. Yeah, that's not bad at all. All right. So, to absolutely no one's surprise, we're going to be continuing with Fusion 360. Although we are rapidly approaching the end. We're just about there. We've got this lesson and maybe some of Wednesday, and that should do it. So, if you've been looking for a light at the end of the tunnel, rejoice. It's here. Anyway, I'm going to go ahead and open up Fusion 360, and we're going to spend a little bit of time going over what we did last Wednesday, because I know some of you guys weren't able to make it because of, well, the hurricane or the tornado, take your pick, really. And, whatever. Various reasons. We didn't cover that much on Wednesday anyway, because I was still not feeling well, and or I was feeling unwell even then, whatever the tense you prefer is. And with those two things combined, we didn't make a whole lot of progress. So don't worry, you didn't miss a whole lot. If you saw the video, that was certainly made apparent. Um, it was mostly just getting it set up in cam mode and all that stuff. So nothing too crazy. Let's go ahead and get it open. You are all set with the latest update. Thank you. We'll go to bookshelf 7 p.m. because that's what you guys are. So essentially, the model was finished. Everything was rooted where it was supposed to be. Um, there was one additional thing we did after doing all the dog bones, and that was we extended the depth of these blind tabs by a 4/100ths of an inch. So like a very, 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 very small amount. And that basically just makes it so there's a little bit of like space to expand in case, the wood happens to warp or change dimension, because that's very much a thing that wood will do based on different temperatures and well, basically different climates, and even manufacturing irregularities that can express themselves when you're cutting it. Like maybe I don't know, depending on the wood, type of wood you get, maybe there's a knot there or something like that, and it kind of messes with the with this top tab. Who knows? Probably not going to be the case, but stranger things have happened. At any rate, that was what we did to finish out the model, was we just extended these pockets by 0.04 of an inch. That is 0.04 inches. It was a very, very small amount. Really wasn't a whole lot to be spoken of. And then we moved over into cam mode, where I started rambling on about setups for an extended period of time, caught my breath, and then we created one. For those of you who weren't here and weren't able to see the video, essentially setups are just, and if you didn't, that is totally understandable. For some reason, it didn't upload the night of. I went ahead and uploaded it the next day. So it is up. It's been up for a while now, but I don't know what happened that first night. At any rate, it's back now. Or the one from Monday. Yeah, the one from Monday was the one that screwed up and didn't upload. But the one from Wednesday and Monday are both up now. At any rate, we went into cam mode. I started talking about setups, and basically setups are just you create starting conditions for your model which simulate the stock and the conditions of the CNC machine and everything like that, so that you can basically properly simulate the actual cutting of the material. And that was really all that involved. I'm actually going to get rid of this 2D pocket because we're going to redo that one with some different settings. Nothing too crazy. We'll just go ahead and go over it again. So if you were with me last Wednesday, I apologize for the wasted time, but just go ahead and delete that 2D pocket so we can redo it. The setup was fairly straightforward. Basically, we just gave it the dimensions of the stock that we're using, which was 48 by 96 by 0.725, which is the ply thickness that we've been using in the model mode. And the reason why we didn't just type in ply is because Fusion 360 is, well, there are a couple places that it can be improved upon. It's a great program, but there are a couple places it can be improved upon. And one of those things is that it doesn't keep your presets between different workspaces, this being the cam workspace, and we were just in the model workspace. So all of those user presets we created applied only to when we were creating the model, and they're all forgotten for cam mode. If we went back to model, it would remember them again, but we can't really just transfer them, unfortunately, easily. Made sure to put all of our units in inches. Not a huge deal, because when you're typing in dimensions and things like that, you can still type IN after the number. So instead of just typing 96 for the stock, I could have typed 96 space IN, and it would have known I meant 96 inches. The shorthand for inches. I mean, you guys all knew that. But it does lock nicely to the grid, and it is useful for simplicity's sake, certainly, and to ensure that we're all in the right units. Because there's going to be that one time when it just slips your mind, you don't think to type the shorthand for inches, and you're going to type 0.725, and it's going to be 0.725 of a millimeter, which is going to be entirely too thin for this material. It's going to stop right there. Maybe it might actually be about that thick, the thickness of that line. Anyway, we made sure to set up our axes too. So Y is pointing along the 48 side, X is pointing along the 96 side, and Z is pointing straight up. Oh, it'd probably help if I didn't have the screen paused. I apologize. Yes. This is, yes. I am in the program. Thank you for pointing that out, Aiden. I apologize, everybody. So, to recap, this is our setup, 48 by 96. thickness of ply. And you can switch modes by this upper left-hand menu right here from model to cam. A setup is necessary, again, to simulate the conditions under which the CNC machine will be working. You can actually create G-code, that is to say the instructions for the machine to cut things out with each individual setup. So you can create different setups for different tools under the same machine. So you can run a setup program, then the machine will finish, you switch out the cutter on it, and then you run the next setup program. And maybe you run 2 or 3, and then you have your final product. This one's only going to be 1. It's going to be nice and straightforward and easy because we're going to be using the same cutter and the same feed rate and RPM and all that good stuff. So that's all going to be standard across the board here. So we can keep this all within the same setup. Excuse me. I apologize. I had to drink some water and have a coughing fit. The advantages of being sick. Anyway, yes, like I said, we had our axis down here, Y along the 48 side, X along the 96 side, and Z pointing straight up. And it was down here in, I guess, the lower right-hand corner, depending upon your perspective. Anyway, that corner over there. Along the x-axis, which is aligned with the, or along the x-axis. As you can see, here's the x-axis, there's the origin. So, now that we've created that setup, we're going to go ahead and start making our first cuts. There are going to be 3 sets of cuts for this particular design, and that's it. So we're going to do 3 different cut commands, all with more or less the same options, and then it will be ready to go. So the first thing we're going to do is we're going to go up here to 2D, click the little drop-down menu, and we're going to go to 2D Pocket. If you mouse over it, it's got this weird kind of doodad that's got all the blue lines and the green lines and the yellow lines in it. Go ahead and click that one. So this is the first thing you're going to see anytime you go into a cut menu. It's going to be the Tool tab. Now the Tool tab is where you, as one might assume, select a tool, as well as the parameters that the tool is going to be working on. So we're going to select, actually it's up here, perfect. For you guys at home, maybe you have one up here that's a 3/8 inch tool. Maybe you don't. If you don't, that's fine. You can just scroll down and find a 3/8 inch tool. You'll notice that there are a whole bunch of different options for a 3/8 inch. The one I selected, it was, well, why don't I go up and look at that one? It was about 1/3 of it was the light gray and 2/3 of it was the dark gray. They all really essentially have identical properties. I apologize for clearing my throat on a hot mic. But just for consistency's sake, if you can find one that looks like this one, select that one, and then we'll continue with that one. And I guess just raise your hand because there's a lot of, once you've got that tool selected, because there's a lot of sifting through the tool parts list in order to find the proper one. Okay, we got a couple of hands up. We had 4 hands. Now we have 3. Now we have 4. we did have 5. Okay, cool. That's more or less everybody. All right. So now that we've got that selected, we've got the tool. It's the number 1 3/8 inch diameter flat. That's what that circle with the cross through means. It means diameter. Real straightforward. It's just a shorthand for it. Now we're gonna change a couple of the parameters here. So under spindle speed, notice it's 3,676.02 revolutions per minute. We're going to change that to a nice round 10,500. It should automatically change the ramp spindle speed, which is perfect. And the surface speed will automatically update, as well as the feet per tooth and the feet per revolution. All that stuff will automatically update. We're going to change a few more things, though. Cutting feed rate, just go ahead and type in 60. 60. It will automatically update to inches per minute, which is perfect, exactly what we want. Do that for the lead-in feed rate, the lead-out feed rate, the ramp feed rate, and the plunge feed rate, in addition to the cutting feed rate. So cutting, lead-in, lead-out, ramp, and plunge feed rates should all be 60. Whereas spindle speed and ramp spindle speed should be 10,500. Now, surface speed, feet per tooth, and feet per revolution will automatically calculate themselves based on the other stuff that you entered in. So you can leave those alone. That's totally fine. But once you've got that done, should be, I say should be, if Fusion is working properly, that will be the last time you'll have to do that for the rest of this basically model. It will automatically set these options to these values and set the tool to the one that we picked every time we do a new set of cuts on this. So with tool done, at the tabs along the top, we're going to go ahead and select geometry. Now, geometry is just a really fancy way of saying what stuff you want to cut. I mean, really. So when we're talking about pocket selections and all that stuff, it just means what holes are you going to cut? In this case, we are going to cut all of these blind tabs along the top. And the way that's done is you would think you would just click, on this bottom part and it would figure itself out. But for accuracy's sake, we're actually going to select the edge where the wall meets the bottom of the blind tab or top, depending on what your perspective is. So, this lower dog bone here, go ahead and click that. It will think about things. And you notice how mine turned, like the entire thing turned blue. Not okay. Ideally, just the inside should be blue. So if the inside of yours is blue, fantastic. If it's not, you'll notice that there's this little red arrow right here, and it's on the outside of this dog bone contour. Just go ahead and click it, and it will flip around. So now it's on the inside, and just this inside area is blue. And that means that we've properly selected the inside of this pocket to be cut. Otherwise, it would cut everything around this dog bone right here. So the CNC machine would get started, and it would just cut everything over here and over here and over here, and you'd be left with a nice little like dog bone shaped piece of wood. It's like those cartoons where they cut down an entire tree and then the whole thing gets whittled down to a single pencil. Or if you're thinking of The Simpsons, a single bowling pin. It's a bit wasteful, and that's not what we're looking to do. So let's go ahead and do that with all of these. So again, you want to select the contour. And again, if it's selecting everything as blue, click the arrow, flip it to the inside. Contour. Sometimes it will automatically select the right thing. That's great. It just means you got lucky because it guesses 50-50 chance. I guess under the guise of being a smart interpretation, but just from my experience, it just randomly guesses the inside or the outside. So make sure to specify very explicitly that you just want these blind tabs cut out. So that's our geometry. Perfect. Heights is the next tab. We're going to leave that one alone. Pretty much never going to touch heights, at least not in this class. It's not going to be that often that you're going to touch heights in, CNC machining in the future. I could be wrong, in which case I'm going to eat my words, but the number for the cutting feed rate is 60 inches per minute. You can just type in 60, and it will figure itself out. No problem. Okay, so underpasses. Now passes is where we're going to start messing around with stuff again. Tolerance we're going to keep the same. Basically just means like how much sort of error we can have in the cutting. Actually, here's a pretty good explanation right here. So if you're cutting something that's got a curvature on it, an unusual curvature like an ellipsis or a spline. A spline is just basically a fancy name for a curved line. If you have a very low tolerance, like let's look top down at this dog bone. So these curves at the edges here. If we had a fairly low tolerance, we might see something like this straight line right here. Imagine that I can draw straight lines. Would look fine. And then you'd have a straight line that goes, that goes like out to here, and then another straight line, and then another straight line, and then another straight line, and so on and so forth. So it would look more like some sort of, I don't know, dodecahedron or something like that, rather than an actual circular piece of wood. A very high tolerance means that it's going to be closer to an actual natural curved shape. So it's going to look closer to the model that you created. If you're not worried about, accuracy, like if it doesn't have to be a curved line, then you can go with a pretty low tolerance. Why did it go back to heights? Okay, there we go. If you need accuracy, if you're not concerned about how long it's going to take to cut, then you go with a very high tolerance to ensure that you have as close to the model as possible. Sideways compensation. Sideways compensation just refers to the direction that the mill moves. It's always going to spin the same speed, but it refers to the direction that the mill moves relative to its spinning. We're always going to use, for these cuts here in this model, we're going to use conventional milling. So for each of our 3 cuts, it's going to be conventional milling. Finishing passes preserve order both ways. Maximums, like the rest of the stuff in passes, you can just leave as is. So we can minimize it right now. Perfect. Normally if you're cutting like a 3-dimensional design or something that is different from this, sometimes you might want to leave some stock behind. Basically, ensure that there's going to be a little bit of left over in case something goes wrong. Or you can cut away a little bit further just to ensure that the design you're cutting is large enough. We're not going to leave any stock behind, so just go ahead and uncheck that. However, we are going to check multiple depths. Now, multiple depths is going to be basically what that means is the tool is going to take multiple passes at our cuts. So like, let's say it's cutting this pocket. It's going to go in once, a certain depth down, and then attack it again a little bit deeper, and then again a little bit deeper, and so on and so forth. Sort of cutting it away in degrees, as opposed to going as far down as it needs to, and then just sort of throwing all the material out of there. Um, Multiple depths kind of helps with uh, keeping the material from breaking as much. It's easier on the tool, stuff like that. So we're going to go ahead and change the maximum roughing step down to 0.1875 inches. The relation to that is it's half the diameter of our cutting tool. But that's really it. It's not like it's gonna, make a huge difference. It's just it gives us a nice sort of uh, a nice value to step down with. That's not going to be, too crazy precise or anything like that. Same with the finishing step down, 0.1875. So now maximum roughing step down and finishing step down should both be set to 0.1875. When that's done, we can move on to linking. Linking we're going to leave largely untouched except for ramp. Go ahead and expand ramp. Under ramp, you've got a whole bunch of different ramp types, and if you click this list and mouse over one of them, it's going to give you a nice little explanatory picture of each of these. The lines, by the way, are the path of the cutting material. Excuse me. So as you can see, plunge, it's just going to head straight in and then start cutting. On zigzag, it's going to do a nice little cut back and forth in order to get down to the material that is actually cutting. Profile is going to try and follow the shape of the cut once it actually gets down to the material. Smooth profile is going to be a nice little circle, and helix is going to be, it's more of a spring, like a spiral. Whereas smooth profile does some sort of weird wiggly stuff at the bottom. Anyway, we're going to do a plunge. You might want to do something like helix or smooth profile or something like that on a stronger material, just to ensure that, again, you extend the life of the tool, make sure it lives as long as possible. Don't just like slam it into some metal and start running it around with the metal screeching and blah, blah. It'd be terrible. With wood, though, you don't really have to worry about that so much. So you can just set it to a nice, simple plunge. It's just going to head straight down in there, cut around, done. And we seem to be having an issue. Clearance height must be above the retract height. Okay, probably was just me when I was trying to figure out what was going on and it was clicking around. All right, so we'll hit OK. And if we look over on the tool after it's done thinking, you've got sort of this nice little set of lines here and this weird cylinder hanging out here. Yeah, I zoomed in way too far. There we go. This weird little cylinder hanging out here. This represents the cutting tool, and the lines represent the path that the cutting tool is going to make. So as you can see, it makes a few passes inside of this hole, and then moves on to the next one, does the same thing, makes a few passes, and then moves on to the next one, and so on and so forth until we hit all 6 of them. Yeah, 6 of them. So that's one thing down. Next, what we're going to do is we're going to set up a cut so that all of the holes are cut out in all of these different shelves and walls. So let's go ahead and do that too. This one, however, click the 2D list, drop down. This one's going to be a 2D contour. Now, a 2D contour is great if you're trying to cut out some material from a stock that's like the same thickness as the stock. You're not trying to leave any walls behind, stuff like that. Which is perfect for these holes, because all we're doing is we're just cutting holes straight out of the material and not really worrying about leaving any behind. So I'll go ahead and click on that. As you can see under the tool, it brings up the tool that we're using, as well as all of our parameters. Fantastic. Now geometry is going to take a little bit longer. Geometry, we need to select every single hole that exists in this bookshelf, except for the blind tabs, because we already did those with the 2D pocket. So let me just go ahead and start with this back wall. I'm going to click again at the bottom here. Notice how the arrow's inside. We want that to be inside. That's perfect. This one can be a little bit more difficult to tell because it's not necessarily going to be glaringly blue, if I remember correctly. I could be wrong, though. At any rate, if the arrow is not inside of the contour here, then go ahead and click it so it is. This one seems a little bit better at properly guessing the correct direction. So maybe I was wrong. Maybe it does have some sort of intelligent. Nope. There we go, on the outside. So go ahead. As you can see, this one's a little bit more difficult to tell because the rest of it doesn't turn blue. The only way I know is that the arrow is sitting on the outside of the shape. So I'll go ahead and click it. It's on the inside again. Don't worry that it's pointing towards the line or like pointing outside. It might be a little bit hard to tell if you zoom out too because it keeps the arrows the same size so it looks like it's outside. So if you're not sure, zoom in until the shape is much larger than the arrow so that you can get a good feel for what side the arrow is on. Click. And that's fine. And that's fine. And that's fine. That one's fine. That one's fine. That one's fine. That one's fine. It's a fun game. Let's see how many times they say that one's fine before we're done. Ha! The answer is 0. This is all ready to go with this as far as geometry is concerned. Perfect. Under heights, we're going to leave that untouched again. Under passes, we're going to do multiple depths one more time. Also, make sure your sideways compensation under passes is conventional milling, because that's really important. You got to make sure it's conventional milling. Now, maximum roughing step down, once again, 0.1875. And finishing step down, 0.1875. This is just, it's not like a scientifically proven amount or anything like that. It's just a nice number that works. So that's what we're working with for the step downs on this, is half of the diameter of the tool, again, to reiterate. So perfect. We got multiple passes selected, and we've got conventional milling, and then we've got the proper step down values for these multiple depths. Under linking, we don't even really have to do anything because we don't have to ramp. Like, that doesn't even matter. We're just cutting these holes. Like, don't even sweat it. In fact, if we really wanted to, we could do a 2D pocket of this as well. Because really, a contour, all it's meant to do is just go along the edges, and it doesn't worry about the stuff in the middle. So if we, if these were larger, basically there would be like a piece of stock in the middle which wasn't connected to the rest of the material. In some cases, that may be an issue. In our case, that's fine. We want these to be empty anyway. So even if there's like a little teensy bit of stock left over in the middle, like just like boop, just like a little tiny bit left over because the cutter couldn't reach it exactly. That's fine. It'll fall out. We'll have our nice hole. So that's it for the 2D contour on the holes. And as you can see, once it's done thinking about it, it will then render its tool path that it's created, which is this incredibly wiggly roundabout path. I don't know why it's doing that, but hey, I'm not a computer, so who am I to judge? It's going to start in the middle here, it's going to go up, and then it's going to double back along here, and then it's going to double back again, and it's going to go a long way around here, and then all the way down here. I don't know. It doesn't make any sense to me. I don't question it, though, because I don't have to cut it myself. So we've done that now. We've done the cut for the this, and we've done the cuts for the blind tabs. Perfect. Now what do we have to do? What do you guys think? I guess I've said it several times, so shouldn't really be a surprise to anyone, but just keeping you on your toes. What do we have next? I'll give you a hint. What's wrong with that picture? Okay, no takers. All right. Well, we have to cut it out from the stock, right? We've cut out the holes, but we haven't actually separated the parts of the bookcase from the stock. So that's going to be another contour cut. Let's go up to 2D and then 2D contour. Tool selections kept the same. Fantastic. Now under geometry, we're going to select the bottom of all of these. And again, it's going to be a little bit trickier to tell, but you want to make sure that the arrow is on the outside. Look at that, arrow on the outside. This time we want the arrow on the outside, not the inside, because otherwise it's going to cut them and make them a little bit smaller than normal, and nothing's going to fit very well. Where's the arrow on this one? There's the arrow on this one. And that arrow is on the outside. And this arrow is on the inside, so let's swap it. There we go. Now it's on the outside. This arrow is on the outside. And this arrow is on the outside. I bet that never gets tiring to hear, huh? And then this arrow is also on the outside. What a surprise. And what about this arrow? This arrow is... This one's on the inside, so we click it, flip it to the outside. Whew, that was exciting. Nothing quite like selecting things to cut. Now, let's not move on quite yet. There's one more thing we're going to do in this area. Now, when the parts of the bookcase are going to be cut out of stock, we're going to run into a little bit of an issue, potentially, when they're fully cut out, in that they are now completely loose and not a part of the CNC machine anymore. This can, they can move around from the CNC machine operating. If you're particularly unlucky, and these pieces are small enough, they could go flying off after you're done cutting it out. Like once it hits the last little bit and the thing's still spinning, it's going to pop up and it's going to pull up the little, thing you just cut out with it. And because it's spinning, it's going to go fling it off somewhere into a garage wall or something. Worst case scenario. But regardless, we want to make sure that these are a little bit more anchored to the stock that we're cutting it out of. We'll basically have it do most of the work, and then it'll leave us to do like some really simple kind of cutting at the very end there. So to that end, we are going to create some tabs. That's all. Nothing crazy. So go ahead and click that checkbox. Now, tabs, what they're going to do is they're going to leave a little bit of material behind, again, so that it's still technically attached to the stock, and then it's simply a matter of just kind of punching them out on your end. Under tab shape, well, you have two options, rectangular or triangular. We're going to make some triangular tabs because we like to live life on the edge. Things are crazy. Tab width. The tab width is going to be 0.375 inches, should be fine. The tab height, we're going to have the height be the A little bit smaller than each pass made by the CNC machine. Yeah, so this is going to be 0.185. I put in 2 points there. Yeah, 0.185 inches. That's going to be the tab height. That way, they're not going to be too thick that it's going to be difficult to punch it out or anything like that. Tab positioning, by distance, again, Fusion 360 is going to do its best to determine where the tab should go, and it's going to place them roughly 3 inches apart. Let's not do that. That's going to be way too many tabs. Let's go at points. At points allows us to manually select where these tabs are going to go, and that's going to make our lives easier, both in the amount of time it's going to save in the cutting and also knocking the pieces out of the stock because there's going to be fewer tabs keeping it in place. This one's really simple. You'll notice that tab positioning is selected at points, tab positions is selected, and if I mouse over bits of it, I get this blue X. It might be difficult for you guys to see, but if you're doing it along at home, you should see the blue X if you mouse over one part of the bottom edge. I'm just going to go ahead and place a couple near the edges here. So as you can see, there's really no scientific kind of measurement going on here. I'm just clicking the edges. Ideally, I probably should have had them be like at least a reasonable sort of symmetry between the two. So I'm going to try and do that by eyeballing it. Good enough. And then we're going to do 2 more on the other side. Again, sort of a reasonable symmetry. And that's, more or less good enough for that particular part. As you can see, we've got 4 tabs, roughly the same distance from the center. Not so down here, but relative to each other, yeah, sure, but yeah. Anyway, we'll go ahead and do that with all of these. Just add 4 tabs to each one of them so that we've got a little bit more stability on our project. And as you can see, I'm not even really worrying about it too much. There and there, there and there. Flip it around. There and there. There and there. And there, I said. Just adding tabs all willy-nilly. And with that gives us 4 tabs on each part for a total of 28 points. So I've got 4 tabs on the back, 4 tabs on the left and right hand sides, respectively. 4 tabs on the bottom shelf, 4 tabs on the top shelf, 4 tabs on the top of the bookcase, and 4 tabs on the kick plate. And if we zoom in, and you can tell because there are these little white dots on each of them, if you zoom in far enough, you can see there's this little triangular prism there. Not quite a pyramid. That's great. That's the tab that we're going to be cutting out of the material. Under heights, again, keep everything as is. Under passes, make sure it's conventional milling. Multiple depths, 0.1875, 1875. Perfect. And under linking, keep everything to its default. Now hit OK, and it's going to spend some more time thinking about it. When that's done, though, we should have a toolpath. Look at that. Toolpath running around all this stuff. Oh, bam. Now, those of you who were here on Wednesday got to see the majesty that is the simulate function. But there was one thing I didn't show you about it. And for those of you who weren't here, you didn't get to see the simulate function. So I'm going to go ahead and show it to you right now. So we'll go ahead and click on setup. So now the stock is showing, sort of. There's like a ghost stock. And then under actions, there is this sort of half dome with a peg on top. That is the simulate part of Fusion 360. Basically, this just gives you a computer simulation of what's going on with the toolpath. Now here's the thing I didn't show you. You can click this check mark next to stock, and what it's going to do is it's actually going to show you what the whole thing is going to look like inside the stock and everything. So if we were to, it's a nice reflective metal, which reflects exactly what we're going to be cutting it out of, obviously, naturally. And then you can just hit play, and you'll notice that the tool is running along its merry way, cutting it along in stages, going, slightly deeper each time, leaving behind some material before it cuts it out, yada, yada, yada. But this can be very useful for seeing if, you're running into an issue where the material is butting up against some other stuff. Like maybe you've got a little bit more of a complex cut, and the cutter can't actually like move in that direction to cut it out. It runs into some of the other stock or something like that. In which case you generally get a red line like you've got here. This one here is just because it retracts too far upwards, according to the simulation, once it's done with that cut, but don't worry about it. The CNC machine is going to retract up exactly as far as it needs to when it's done with those cuts. Now it's getting to cutting the holes. We can affect the speed by dragging this little slider around, so we can make it go like super fast or really super duper slow, or we can have it go backwards if we'd like. So we're going to have it go forwards. We're going to get to the part where it starts cutting out the different pieces, and we're going to verify that those tabs appear. Go, go, go. So now it's starting to cut out. I guess that is the right wall. So it's going, it's going, it's going. And what we can do is we can zoom way in on an area where we know that there's going to be a tab. Wait for it to come back. There we go. It's making its second pass here. Cutting, cutting, cutting. And we'll speed it up a little bit so it can come back. Whoa, too fast. I cannot seem to find a happy medium. There we go. Yep. You'll notice right here, whoa, that reflection. I like how there's a scaffold on this reflection. I wonder what exactly it's reflecting. Anyway, you'll notice right here that there is this sort of triangular shape. This is the beginning of our tab. So once it starts making another pass, or once it gets here from making another pass, you're going to notice that that triangular shape deepen. So it's really slow. I'm going to speed it up again a little bit. Okay, there we go. Zoom way in. I had to pick the last tab too. I mean, technically I could have moved over to any of the other ones and you could have seen it, but here it goes, and then it's going to like kind of pop up a little bit for a second and then go back down, and here's our nice triangular tab. Make it easier to cut. And then it's going to finish off the edge right there. Boom. Done. Moving on to the next thing. And if you're so inclined, you can just watch this for the entire cut. Apologies. Another coughing fit. All right. So let's say that we've watched this thing do its little cutting duty and we've been impressed with it. Like, so far, so good. Everything looks fine. It's ready to go. Well, what do now? Let's go ahead and close this. We're not going to simulate it anymore. Now you'll see the second option under actions. It has a G2, G1 and a G2. Guess where the name G code comes from? Well, it's just a bunch of different actions. But anyway, listing of commands. What we're going to do is we're going to click that one. And yeah, we're going to reset to the basic one. So we got a whole bunch of stuff right here. Under post configuration, go ahead and click the drop down and make sure it's on shopbot.iso.cps, which is shopbot.iso. Because that's really what we've been assuming the whole time we've been making this is going to be made with a shopbot. Obviously, you would select the machine that would be appropriate to whatever you're using if you're using a different brand of CNC machine or whatever. Configuration folder and output folder. Make sure the output folder is where this is going to be saved to. So make sure it's saved to somewhere where you can find it. I'm going to save it to the desktop because I don't have enough stuff on there. So we're just going to select the desktop. Okay. And then give it a useful name. Now, the thing about machining with a CNC machine, you know how I was saying before how like the setups, this doodad over here, you can organize them by tools used and stuff like that. So a useful name in this case might be, you know, like your name, bookcase 3/8, representing that this is your bookcase, and this is the particular tool path being taken by the 3/8 cutter. Not necessary in this case because our only cutter is the 3/8 cutter. But, you know, let's say you had a 3/8 and you had a 1/4 and you had a, you know, 7/16 and a 542 1028 and just all kinds of different stuff. You could name these by the particular cutters that they're using. And what we're actually doing right now is we are outputting just this setup. A bit of a moot point since we only have one setup, but if we had a second one in this post process, we'd only be working on this setup right here. So you export one setup at a time. So again, that's why we used all the same tool here. Other than the fact that we were gonna anyway, it's just handy to keep it all within the same setup. So I'm gonna call it Detoy Bookcase 3/8. Let's do an underscore because I'm good at naming things. And then we're just gonna hit post. And it's going to ask us, again, to save it. We're going to hit save. And it's going to beep boop for a little while. The computer's going to think about stuff. And it's going to open up in brackets, which is basically a program that came with Autodesk Fusion 360 so that you could look at G-code. And here's our completed G-code. This is just basically a set of coordinates that the CNC machine moves to. So it's like start here, go here, go here, go here, go here, go here, blah, 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 blah each time. And it was a whole lot of cuts because it's going to go in a lot of different directions. Um, and it's got to be very specific about it, in case you want to make like a circle or something like that. That's where the granularity thing exists. That basically how circular do you want to make a circle kind of option, the tolerance, is because it has to calculate a coordinate for the tool to move to for each point. And as you make it more circular, you add more points. So, something like that, it has to move in a straight line to each of these points. That's going to be far fewer different commands than something like this, which will maybe have this many points. You get the idea. I'm not going to draw them all, but um, that's where a lot of times the speed can come in too, because it has to load all these instructions as it's doing them, and they're not exactly memory-intensive instructions, but whatever. Your computer has to make the instructions too, which can increase the amount of time it takes for your computer to translate this into G code, so on and so forth. So that's perfect. Now you've got your entire bookcase exported into G code. Now all you need to do is you need to find a piece of wood that has the exact same dimensions and a CNC machine with a 3/8 inch cutter, and you can plug this in, like put it into onto a USB thumb drive, plug it into the CNC machine, assuming it's a ShopBot, and then just have it go. And then before long, you'll have a bookcase. Really and truly. So actually, that does it for CNC and Fusion 360. Uh, Pretty much a cool month and a half after we started. It was a long lesson, but I thought it was pretty cool. I don't know about you guys, but I thought it was pretty neato. At any rate, I'm going to go ahead and throw out the poll questions. Not discard them. I'm going to give them to you. And then afterwards, if you have any questions, feel free. Otherwise, you're more than welcome to head out. Makaya, I know you need some help with yours, so I'll go ahead and help you out with that. Otherwise, same thing, everybody. If you've got any questions, now's the time. All right. 100%. Good. I'm glad that the pacing was good. Uh, my lessons tend to start out really slowly and then speed up more and more as time goes on. Just because I spend a lot of time explaining the concepts behind things at the beginning and then just not doing it again later. I'm just like, you've seen this before, do this again. So, um, as long as that continues to work, then fantastic. There was the every answer bomb. I just saw that drop. All right, 71%. So 5, 4, 3, 2, 1. Clues. All right, 60 and 60 and 20 and 20 and 20. So, I'm going to take the two 60s in that case. And I'm glad that on the whole, it was pretty good. But anyway, like I said, that does it. If you have any questions about anything, I'm here. Doesn't have to be applicable to the lesson, whatever. Otherwise, you're more than welcome to head on out. Have a good couple of days. We'll see you on Wednesday.